So now I would like to present Elisabeth Walter from Germany. Give her a big applause. Yeah, yes. Good luck.
Oh. Hello everyone, my name is Elisabeth and I'm from Germany. And last year I had the chance to conduct my high school research project at CERN near Geneva. My goal was to search for heavy neutrinos in so-called kaon decays. But what are heavy neutrinos and why are they interesting? They have been introduced by certain standard model extension theories, and they are so interesting because they are candidates for dark matter, and they also might explain why we see more matter than antimatter, and how the standard model neutrinos gain their masses. And therefore, they might also explain neutrino oscillations. I wanted to look for them in kaon decays. A kaon is a composite particle consisting of an up quark and an anti-strange quark, and I wanted to see whether it's observable that a kaon decays into a heavy neutrino in the final state. To do this, I could work at a CERN experiment, which is called NA62, and they use protons that collide with a target, and by this, kaons are produced, and these will be measured in primary detectors. And as the kaon has a certain lifetime, they will decay in the vacuum region. After the vacuum region, there will be secondary detectors. Fun fact, the distance from the target up to the secondary detectors is about 250 meters, so you can actually have a nice walk going around there. For my decay, I would expect that there will be a muon in the secondary detector and nothing else, because the heavy neutrino is invisible to the detectors. So I have to reconstruct the track of the heavy neutrino by using the kaon track and the muon track. The second part of my program was to filter interesting events. There's a lot of stuff happening at this experiment, so I just want to look at events where there's one distinct muon and one distinct kaon in the detectors. Also, I want to avoid interactions with detector material. Therefore, I cut on events where the decay happens within the vacuum region. And sometimes it happens that tracks are falsely reconstructed. Therefore, I just cut on events that have coincidences in distant detectors. So let's see at the results of this. Here you can see the two-dimensional histogram. And on the x-axis, there's the muon momentum. And on the y-axis, there is the neutrino mass squared. And these two areas are basically background events that I want to filter, that I want to lose them. And the most entries are at neutrino mass about 0. This is due to the standard model decay mode, where there is a standard model neutrino in the final state. And as you can see there, this has the exact same signature as the decay I'm searching for, so I do not want to lose too much of these entries. And after my filtering process, this worked quite well, but there's also a different background decay mode that I have to consider. So while evaluating my data, I need to consider these background modes, and I can do this by comparing simulations to actual data. You can see the simulations in green there, and the data in black points. And this is due to the standard model decay and also the other standard model decay where there's a pion involved. And as you can see, when you look at the difference of the Monte Carlo simulation and the actual data, you can see that the difference is not very significant. So if there was a hypothetical new particle in this area, there should be like a huge difference, but there isn't. So therefore, there are unfortunately no hints for heavy neutrinos in this mass range. However, I did not process enough data to give a clear answer to that now. But using my program, one might be able to establish a upper limit on the production of neutrinos, heavy neutrinos in kaon decays. Thank you so much for listening.
Thank you so much for this interesting speech. Do we have any question? Down here.
Hi. Are there plans for any future research to be conducted to get a definite answer to whether there can be heavy neutrinos this range, or are you planning to move on to further research?
Are you asking me for myself, for personal, or?
I would, no, in general.
In general,
And
okay.
personal.
I think in general there's lots of research happening for searching dark matter candidate particles. There's lots of research going on, yeah.
Okay, thank you.
Is there any other question? No? Okay, all right. So thank you very much. Thank you.